Structuring your application code is only really part of the problem. You can think about code design, you can think about separation of concerns, think about structuring your code base in the right way, and it can be the most beautiful piece of code in the world until you need to connect it to something. If the code you write to perform a task needs to connect to some kind of message channel, a queue, a topic, a stream, a bus, you introduce a whole lot of extra decisions. How do you deal with errors? Do you write an anti-corruption layer? How do you manage coupling? How do you deal with message schemas and validation? Maybe your message handler is going to run on a container. Maybe it's a serverless function. In that case, how would you even test it? What was a simple, beautiful piece of business logic has suddenly become an awful lot more complex. And that's what you're going to learn about in this video, how you can keep that simplicity in your code whilst making all these other decisions about your application code.
James, am I right to assume that this is going to be another thing where hexagonal architectures can help us out quite a bit? I'm thinking in particular about the last video where we talked about the same problem, but for synchronous applications, and in particular, how we can use things like 12-factor to make this a bit simpler.
Yes, 100%. Like the perspective of how you're going to run this thing, then definitely all the stuff that helps you with a synchronous system is exactly the same as will help you with an asynchronous system, like 12-factor app, like you talked about, how you deploy it, how you package it. I think the fundamental thing I want to touch on in this video is the way you would separate your business logic itself, the thing that you've written to solve the problem, from the actual infrastructure or the thing that maps to the message handler. And I don't often like using the word always in software development, because obviously there's so much nuance in all the things that we do. But this is one of them places where I think I do start to sway towards always.
Okay, but so super concretely, you have something that needs to be driven off of a queue. As a Kubernetes maximalist, I think the simplest way to do this is to just use a container. Write a container, it has a process, it connects to a queue, it starts polling it, it does work in response to that. You can pick this up, you can drop it in any container orchestrator you have, you can be happy.
Yes, and I think the happiness and the simplicity there is a really good thing in a lot of cases. Like if you're set up, like we talked about in the last video, if your entire organization is a container shop, they use containers, great, do that. It's simple. But the problem I always see with that is that now you've got a container image running 24 hours a day, 7 days a week, 365 days of the year, even if there's no work to do, which you could also argue is the same for a synchronous web app, right? But synchronous apps, at least in my experience, I don't know about yours, typically care more about latency than an asynchronous web app. So I do think there are some optimizations here. And this is where I think the use of ports and adapters gets really powerful, because it allows you to pick the right service for your use case. Run it on a container, run it on a serverless function. It really doesn't matter. All you're changing is the handler around it.
Okay, sure. But doesn't that still mean that a developer needs needs to learn a new way of building things, of how they wire their applications up to each other, of how they connect to the messaging infrastructure, receiving events rather than receiving message calls, or actively connecting out to a Kafka queue? So I can see your argument around waste and optimization, but the developer toil that this is presumably going to involve is probably going to outweigh that to some extent, right?
I agree. Yes. So let's have a look. Let's have a look at an example, actually, and to kind of talk about what I mean. So this, as you very well described, the first way to do this is simply just to have a containerized web app. And this is .NET application code here. It's largely irrelevant what programming language you're using. Most programming languages have a way, a mechanism to start a background thread, start a background process, and run something on a schedule. In that case, in .NET, you do this by inheriting from this background service interface. And then you can write code inside this execute async. And again, regardless what programming language you're using, you're going to be doing a similar kind of thing. You're going to be polling some kind of message worker. This is a little interface here because we support a few different messaging technologies. If we look at SQS, you're going to be doing some kind of poll SQS directly. So we call receive message on SQS. And then you're going to iterate over all of the messages you get back in that batch, and you're going to process the messages. But that is, broadly speaking, how you would always do that in a container. And I totally agree with your point in that, you know, if you're a developer used to just writing code, that's very familiar. You're just wiring up to a different messaging technology, right? And I think that is a very simple way to start. However, I do think in some cases you're picking the wrong tool for the job there, because as a serverless maximalist, to counter your Kubernetes maximalism, serverless functions are built to be reactive, right? They're built to react to things that are happening. That's kind of the superpower of serverless functions. So if we look at that same handler, but for using a Lambda function instead of using a long running container. So this is now something that's going to scale up when there's work to do, scale down when there's no work to be done. You see that actually the code is basically identical. We're calling for each message that we receive from into the Lambda event handler, we're calling process message on that thing. These two process message methods, this one and the one that you saw earlier, are going to be basically identical in terms of how they actually work. So all you're doing is taking that exact same application code because you've practiced ports and adapters, you've separated that polling code from your actual business logic, and the same again here. It gives you that ability to move things around. And then when you layer things like 12-factor app, stateless apps, separating your configuration on top of that as well, it gives you an awful lot of flexibility about where you're actually going to run this app.
Okay, cool. But what about all the other stuff you have to do, like handling dead letter queues or handling changing message schemas for upstream services? The stuff that you don't think about when you write the program to start with, that you do think about as soon as it's being running in prod for a little bit.
I think that's the same problem that's going to exist anywhere, right? I think one of the benefits of this separation between infrastructure code and application code is that it allows you to get really focused on what is the thing that you're trying to solve. So, like, the application code, the business logic is pure business logic that doesn't necessarily need to care about a dead letter queue or changing message schemas or anything like that. That is like pure business logic. And then this, you're working in that context. You're writing some code. You're asking Claude to write some code for you. Whatever you're doing today, you're focused on the business logic. Equally, when it comes to them wiring that up, you've got a different set of concerns now. You know your business logic is written and it's working. Now you can focus on, how do I receive this payload? Do I poll? Do I receive it from a Lambda function? Do I need some kind of anti-corruption layer to receive that external payload in, translate that to something that my business, my logic understands, and pass that on? This is where my error handling would go for returning a message to a dead letter queue, or returning an error, or returning success, or whatever that happens to be. And I think having this really clear distinction allows you to get really focused. Now I'm writing code that focuses on infrastructure concerns. Now I'm writing code that focuses on application concerns.
Yeah, I think that makes sense to me, actually. So we've really bought ourselves a fair bit of flexibility here with our investment in hexagonal architecture and the decoupling of these concerns, I reckon. Basically, we can move things around in terms of infrastructure more easily because we have this separate world effectively in which we're building the application part of things, which means we can shift between like SQS or Kafka or Google Pub Sub, I guess is the Google one.
So yeah.
Nice. Tomorrow, regardless, and again here also, regardless of where we're actually running the thing, whether it's in a container or as it may be in a function.
Yeah, exactly. I think that's the main one, rather than at least in my experience, like the switching of Kafka for SQS or Postgres for DynamoDB happens quite rarely. I think it's the second half of what you said that's the really important one. Like, you can make more pragmatic, sensible choices about where your application runs rather than the things it connects to. But anyway, to get super concrete about things that you can take away, the phrase I like to use is that friends don't let friends leak their infrastructure choices into their business logic. So encapsulate the stuff that is related to your infrastructure choices, encapsulate the stuff that's related to your application code. Encapsulation gives you flexibility, and flexibility gives you that ability to evolve over time. Secondly, start with the simplest possible option. I think this is the same advice we gave in that last video as well. Like, if for you today, you're familiar with containers, you're familiar with running a long-running container on a container orchestrator, polling an SQS queue, do that. If you've got things you need to deliver on time, you've got things you need to do, you've got work you need to finish, do that. But remember, there are other options that exist out there, things like serverless functions that are built with reactivity at their core. Maybe try that out on the side, but for the most part, stick with what you know and stick with simplicity.
Cool. And I reckon, as always, check out Stickerlandia if you want to see this in practice. We have CDK and Terraform to show how to deploy the application to both containers, serverless, and different cloud platforms, all in one repository.